That's what happens when you get to be 80. You know, it's a little harder to get up on stage. So, wow, what a great introduction, Ava. Thank you very much. What a presentation that was. Boy, didn't that just glue you to your seats? You didn't go out for popcorn or more coffee. You were riveted right here, and that's where we're all meant to be, right here, right now. And I'm going to take maybe a little bit of a different approach. I mean, normally I would be giving a scientific talk, and this is going to be sort of borderline science. You'll see what I'm talking about here in a minute. So I'm calling this the challenges and opportunities at the edge of glycobiology. And many of you are saying, oh, glycobiology, yeah, I think I've heard of that. I think that's got something to do with CDG. So I have one conflict of interest, consultant for Glycomine, but that's about it. We talk every now and then. But, you know, this is the way we all think it works. You start out with some sort of basic laboratory research, moves through translational to clinical research, and in the end, it comes out to show you exactly some improved public health. Don't go that way, go that way. And you know, it doesn't work that way. That's how it works. It works because we're all in this together. This is the ecosystem. We all inform each other. Every piece of that contributes and cooperates with every other piece. Now, not every fragment of data is important all the time, but sometimes it becomes really important, and you never know when that time is going to be. So this is true for CDG, and I talk about the CDG ecosystem. And obviously, basic scientists and physicians are talking to each other. Well, but, you know, maybe they don't talk enough. Maybe there needs to be more of that. Well, I would agree with that. But what else is missing from this diagram in the ecosystem? Yeah, everybody here, the families. And so when CDGs first began to be identified, there wasn't a lot of knowledge of glycobiology in the medical and even in the basic science community. And so what happened is, even though the fundamental relationship is between physicians and families, actually basic scientists like myself were being contacted by families saying, my physician doesn't know anything about this. Where do I go? What do I do? Well, lucky us as basic scientists, because then we get to owe something back. And that's been our responsibility. So the big ecosystem requires all of us being together. And if anything, the message you're going to come away with today and tomorrow and on Sunday is we're all in this together. We're part of the ecosystem. And if we do that way, we've got the best chance of success. So there are many needs, and there are many pathways to get there. So how do we work this out? What do we do? Certainly the families are at the center of this, and I think everyone can agree with that. Certainly all the scientists would say that. But I'm going to say SWOT's new in CDG ecosystem. That's not a misspelling in the beginning. That's SWOT. And SWOT means strengths, weaknesses, opportunities, and threats. And yes, thank you. And you have to consider all of those because they all matter. So there are threats. There are anti-science climate right now. There's funding risk, fragmentation. And there is what I'm going to call a workforce gap. What does that mean? Here are the almost current list of CDGs by different sort of metabolic pathways. That's what the different blocks represent. But we're climbing to 200 different disorders. Now, not everybody, not every physician can know everything about every disorder. But what that does is, because there are different numbers of patients, there are different, if you would say, representations of those, and yet we have to pull together for everybody. So there's a certain amount of fragmentation that goes on here. Well, that's the mutation in that gene that your kid has, but how about the mutation my kid has? So, it doesn't necessarily contribute to everybody pulling together. So there is a way around this, though. So one of the biggest problems that I see is the workforce gap. The number of institutions where you have glycobiology training, in other words, the fundamental aspects of what you need to know about sugars and glycosylation in order to begin to absorb this unusual field. Where do you find that? Well, less than 10% of the biomedical PhD programs include any glycobiology lectures. Think about that. Less than 5% have any structured or multi-lecture training. So if the basic scientists are not learning about this, and they oftentimes will be teaching some of the physicians, then the physicians are not going to know. And yet glycans are essential for essentially every organ, every cell, every organism on planet Earth. The consequences is that we have a limited supply of glycoliterate scientists, and therefore they're underrepresented in pharma and diagnostics and clinical genetics. Difference is right here, we're the majority. So there is a bottleneck in translating glycoscience into the discoveries and then into therapies. And so we looked at, I won't go through this whole slide, but you can kind of scan it. The bottom line is that there are very, very few places that are going to be teaching anything about glycobiology. So we need to get the word out. And it's concentrated in just a handful of institutions, even inside the most research-intensive aspects of U.S. biomedical PhD education. You want to see where they are? You've seen a map of the U.S. This is where there are pockets of glycosylation, where that is a focal point, where that is a course. So you can see there's a big gap here. And if people are not aware of that, does your physician necessarily think about this? If you've been lucky enough to start this journey by having the physicians, many of whom are in the room now, then you're in the sweet spot. I guess that's kind of a joke, but you're in the sweet spot because these people will know glycosylation. Most places will not be so lucky. There is also another risk, and that's to funding. Just a week ago, the NIH budget was proposed from the administration, and that would be a $5 billion cut. Now, is that going to go through like that? Well, we don't know. Congress has generally been on our side, but there is a threat, and I can guarantee you every scientist is feeling that pressure. We are worried to death. That's what I say. No. There's more threats. There's an anti-science climate here that we have to contend with. And I read an article here recently that says, my patient would rather take a peptide than a statin. This is uncomfortable. And why is that? My patient refuses a drug studied in 175,000 people because of the side effects. That 124,000 person analysis just confirmed does not exist. It is not there. But injecting a compound studied in 14 humans from unregulated sources based on the recommendation of someone who profits from selling it. They prefer that. And she's probably not the only one. So we have to battle an anti-science climate. And this and you all are the best people to do this, because you know what it takes to help your kids. So there's all kinds of threats, workforce limitations, funding instability, over-reliance on some of the things and not enough in the others. And I think at least one aspect of that, is certainly having the patients at the center. So let's take CDG research from capability to intervention. So we have tools Now, this is not going to be an in-depth scientific discussion. These are going to be terms that you'll be hearing again and again throughout the next couple of days. We have iPSCs. What is that? That's a cell taken from a patient that can be differentiated into different kinds of cell types and organoids. And you can study those organoids. Those are three-dimensional things that are little dots in a dish, but they can tell us a lot. We can do omics, glycomics, proteomics, transcriptional investigations. We can do that all on those things, and we can do it in spatial models. And yeah, we have to start with model systems. We can't just do experiments in people, even though sometimes it doesn't translate from mice or rats or whatever the system may be to humans. That's where we have to start. That's insistence. But now we have AI, and I'm sure everybody has heard about AI, and there is some ways of making structural predictions. That's going to be one of the best ways that we have of going about doing the research coming in the future. Metabolic flux, and what does that mean? That means how fast the material is going through. Look at the little diagram down on the lower right corner. How can we regulate the flow of all of that material? Those are metabolites. Maybe we can arrange those in different ways. And how can we do approaches? Well, you heard about ASOs, antisense oligonucleotides. You heard about gene therapy. That's going to be playing an increasing role. We can rebalance these pathways. Just think about shifting the flow of that river down there into pathways where you might want it to go. We can use small molecules to affect those pathways, to stabilize unstable proteins, to make a way in that is guided by science. And it's not a guarantee, but it gives us a good way to look at things. And of course, always we're discovering new CDGs. And this is quite helpful, because when we get some insight from a new disorder, it can apply to all of the other disorders, and it gives us more insight. So, what are the opportunities? What can we become? So, I think one of the first things is understand the unifying principles. What are the things in common with all of the different CDGs? Can we approach those things? Can we build predictive models that will show you the response of an organism, of a cell, in some way to some therapy that you might be able to put in? Can we develop some platform therapies that we could use for various disorders? That's important. And if we use the human iPS systems, we can make, as I described, these 3D cultures. You're going to be hearing more about this from one of our collaborators who has developed some really wonderful techniques. And so we can leverage the patient communities and all of the samples, all of the information, and we can go from rare diseases, and then we get general principles. So of the big ecosystem, we, as the rare disease people, can contribute to the bigger picture. And you can see that in some of the things that have developed out of rare diseases. Well, maybe I scared you with the threats, but we got a lot of strengths. So the strength is right down here. That was the last CDG meeting in San Diego in 24? Yes, in 24. And of course, that was the river. It's not the San Diego River where we held the meeting, but that gives you an idea of what it looks like there. We have an unmatched patient-scientist partnership, and you can see it all around you. We have trust, we have urgency, and we have a shared mission. And most fields, most basic science fields, don't have that. A compelling human story. I am convinced, we have the best stories. These are the kinds of stories that people resonate with because it hits here. My own sister my own sister who just passed away in November, had a disorder We never figured out what it was. And turns out that I carry the most common mutation in the most common kind of CDG, so I'm really related to a lot of you in here. And I was thinking, what if my sister had this disorder? We sequenced and she didn't, but she was part of the reason that I'm here. Because I know what it's like on that side of the fence, not just in the laboratory. I know what it's like to be in the family where you make the adjustments and where you're always wondering, what the hell is going to happen? Where are we going to go with this? Can we find a treatment? Can we find a cure? We've got stories. We've got great stories. We've got also biology. The glycobiologist, the cell biologist here that are doing all of this work, we know how to work with that. But as you notice, there was not enough of us. So we need more. And they are actionable, as we've been able to find from some of the therapies that have taken place. There is a metabolism glycosylation interface, multiple therapeutic levers. And it's not only just gene therapy. Do we stop there? No, we certainly don't, because we have natural experiments in humans. The reason that that is a strength is that that drives discovery, not just validation. So yes, we may know that this is what your child has, that this is what's important. But we can use this, spread the word around to the greater scientific community, and then we can latch on in good ways to their interest, because we can help other diseases. We have an expanding toolkit that I described a little bit earlier. And now we can study systems at a level we were never able to get to before. We still have more strengths. You thought it was all going to be down stuff. Not. We have many more strengths, because we have cross-disease relevance, neurodevelopment, immunity, cancer metabolism. CDGs are really a gateway into the broader human biology. And I'm going to take a figure from a paper that we had where we list the different kinds of CDG on the left side. And then at the bottom, we're looking at the different systems that are affected. So the more blue-purple you have, the more that frequency is. And what you see is that most of this, not all of it, is neurological. So combining with combined brain, having that kind of orientation is essential. But we also don't forget the GI issues that many of the parents point out to us. We don't have very many problems with hair or teeth, but there are some of those that do. We have proven therapeutic precedents, proof that the mechanism-based therapy can work. And I would say that the investigators, the glycobiologist, and now the glycobiologist scientist, that line, that communication is being far more strengthened in the last decade, thanks to all the people that you're going to hear from. And I have to tell you that all of the glyco people know each other. You could take the entire field of glycobiology, put them in a high school gym in a small Indiana town at sectional time, and you would have the whole field in there. It's not like neuroscience where you have 100,000 people. We're just this little tiny group. But we're powerful, and we're going to get better. And all of us know each other, so there are no sharks here. In some fields of science, yeah, there are people who, you wouldn't necessarily want to be friends with. But we have principled people who are driven by exactly the same thing that you are, to make a difference in the world. We can combine human urgency with a mechanistic clarity. We're not there altogether yet, but we're on our way. That's our greatest strength. But you know what? We have partners. And who are those partners? Well, it turns out that there is a global science roadmap network that is being established. Because I think the glyco field in general realizes that there are new opportunities, new ways to go. And this doesn't only involve the disease aspects. This involves things that you probably never even thought of. And they're trying to target this to research funders, because you're always hearing about the money, government, industry, and praise be philanthropy. Philanthropy has been one of the greatest gifts we've had, and with our stories, it's not surprising. There are working groups. Human health and medicine is groups 1 and 2, but there is nutrition and the microbiome. In other words, all that stuff that lives in your gut. And then there are other ones that look at different aspects. Agriculture, sustained materials, polysaccharides are also glycans, and they're used in advanced materials and energy. Just think of crops and plastics and things like this that can be made from carbohydrates. And there are technologies out there that are being developed too. So each of these working groups has a different function, different focus. But the ones we're interested in here are especially 1 and 2. And I want to point out that, I know many of the people involved in this group. And Dr. Ivan, who started off the meeting, was praised by one of the leaders in this group. He says, "What? Where did this guy come from? You guys are so lucky to have him as part of the CDG operation. Tell me more about him." So you know you're in the right place. We have successes. The polysaccharide-based vaccines are well known. Glycoengineered antibodies can be done because we modify the sugar chains. We can have antibodies that target known tumor glycolipids and are part of a therapy. You can target individual proteins using things such as mannose-6-phosphate. And if any of you have seen the movie Extraordinary Measures with Harrison Ford, most of that is pretty accurate. And it was done in 2011 or 12, somewhere around there. But it's a good film, and it tells you about people that we know and that we've all worked with. And there is mannose-6-phosphate-mediated enzyme replacement therapy. But you know what? If you have ever taken Tamiflu or any of the influenza drugs, they're all based in glycobiology. You didn't know that. But it's all because they inhibit this enzyme called a neuraminidase that is really key in having the virus spread around. Glycosaminoglycan, that's another type of carbohydrate-based therapeutics. Have any of you ever heard of heparin? Or maybe you've taken heparin. That prevents clotting. That is the most frequently used medication in the world, and that's all based in carbohydrate. And certainly the supplementation of some types of CDG with sugars, good sugars. Now, you always hear the bad stuff about sugars, how sugar is bad for you. Yeah, but if you take the right sugar for the right patient, that can make a world of difference. And that is now being expanded to influence the treatment of other disorders. So we have to expand the awareness. Glycosciences are central to disease framing. We need to have glycoscience-informed therapeutics because they're located everywhere. We'll personalize the glycome-aware medicine. And there are such human-relevant models because we have all of you here. These are the patient-centric but patient-relevant models that we can take to the rest of the world. We're going to come up with detailed mechanistic understandings of how these very complicated situations of sugars and being attached onto proteins, how that works. And we are still going to broaden the glyco-related genetic disorders. There are more coming. We have several that we're looking at right now. And one thing I want to point out is that Francis Collins, who was the director of the NIH for many, many years until he stepped down a while ago, he said, "Your best story beats your best data." You have the best stories. You have the best stories. You heard a story from Terry Joe earlier. That's the kind of thing we need. We need you all to go out there and tell your story. You've got to have people to listen to you because you've got stories. And you know what? Back in 2013, when I got this thing called the Golden Goose Award, it was Congressman Rush Holt who said, tell them a story. They understand stories. That's what's got them elected. That's Congress. Who is that? Yeah, that's Congress. We are a force, and together, that force will make the difference in the world and make the difference for your kids and all of your family's future. So what do we have? We have a great rainbow, and what's at the center of that rainbow? It's hope. Yes, it's hope.